Not every database problem requires us to restore everything from scratch. Imagine someone accidentally deletes important data at 10:25 a.m. We don't necessarily want to go all the way back to yesterday. What if we could recover the database to just before that mistake? That's the idea behind point-in-time recovery. Today, we will see how Oracle uses backups and redo to restore to a specific time, SCN, or log sequence. Point-in-time recovery means restoring database file from backup and then applying the available archive redo until we reach a specific recovery target. That target could be a particular time, an SCN, or a log sequence. The important thing to understand is that we are not literally rewinding the database. We are restoring an older copy and then moving it forward using redo until we reach the point we want. Let us use a simple example. At 10 a.m., the database is healthy and transactions are running normally. Then at 10:30 a.m., someone accidentally executes a massive delete statement. The database itself may still be running perfectly, but the data is now wrong. The DBA needs to recover the database to a point before that mistake. That's exactly the type of situation where point-in-time recovery becomes useful. Point-in-time recovery is especially useful for logical problems. For example, someone could accidentally drop a table, performing a wrong update or delete, or an application could introduce incorrect changes. The hardware might be completely healthy. The problem is simply that unwanted changes have entered the database. Point-in-time recovery allows us to recover the database to a point before those changes occur. Oracle gives us several ways to define our recovery targets. We can use a specific time, an SCN, or a redo log sequence. The key is choosing the correct recovery point. We want that point to be safely before the unwanted event we are trying to remove. The first option is time-based recovery. Here, we tell RMAN to recover the database onto a specific timestamp. This is often easy to understand when we are dealing with human error. For example, if an accidental delete happened at 10:35 a.m., we could choose a recovery point shortly before that event. The goal is to stop recovery before the unwanted changes occur. The second option is SCN-based recovery. SCN stands for sequence change number. Oracle uses SCNs to represent points in the database transactional history. So instead of saying recover me to 10:30 a.m., we can specify an exact SCN as our recovery target. This is useful when the precise transaction boundary is known. The third option is log sequence-based recovery. Oracle redo logs are identified using sequence number. In environments with multiple redo threads, the thread number is also important. We can therefore tell RMAN to recover onto a particular log sequence and thread. This gives us another precise way to define where recovery should stop. So what does the recovery process look like? First, we prepare the database for recovery. Next, we recover the required data file from backup. RMAN then applies the necessary archive redo and stop when it reaches our recovery target. Once incomplete recovery is completed, the database can be opened using RESETLOGS. Here's the basic idea. Inside the RMAN run block, we first define our recovery targets. RMAN then restores the database and recovers it using the available recovery information. Once the target has been reached, we open the database with RESETLOGS. The exact command used in production will depend on the failure scenario and database backup configuration. RESETLOG is an important part of incomplete recovery. When we perform incomplete recovery and open the database with RESETLOGS, Oracle creates a new database incarnation. In simple terms, we are starting a new branch of the database redo history from that point. That's why RESETLOG is not something we should treat casually. Afterwards, our backup strategy needs to account for this new recovery history. After a successful point-in-time recovery and RESETLOGS, we should establish a new backup baseline. The reason is simple. We now have a recovered database with a new incarnation. Taking a fresh backup protects the recovered state and gives us a known starting point for future recovery. From there, we can continue our normal backup strategy. Point-in-time recovery depends on having the right recovery components available. We need archive log mode enabled, a valid database backup, and the required archive redo. We also need the necessary control file information and, most importantly, an accurate recovery target. If critical parts of that recovery chain are missing, point-in-time recovery may not be possible. Point-in-time recovery is powerful, but it is not the right solution for every situation. Traditional database point-in-time recovery takes the database back to an earlier point. That means changes made after the recovery target won't be part of the recovery database state. If we only need to recover specific data while keeping everything else current, alternatives such as Flashback or table-space point-in-time recovery may be more appropriate. This brings us to an important DBA decision. If the entire database needs to go back to an earlier point-in-time may be appropriate. If only a few blocks are corrupted, block media recovery may be better. If specific data needs to be recovered while the rest of the database remains current, Flashback or table-space point-in-time recovery may be considered. The key is choosing the recovery method that matches the problem. Point-in-time recovery is only reliable as backup environment supporting it. DBA should validate RMAN backups, protect and monitor archive redo, and protect control files. Recovery procedures should also be documented so we are not trying to figure everything out during an actual incident. And most importantly, test point-in-time recovery regularly. A recovery strategy that has never been tested is not a reliable recovery strategy. Let's summarize. Point-time recovery allows us to recover an Oracle database to a specific point in its history using backup and archive redo. Our recovery target can be a time, SCN, or a log sequence. It is particularly useful for human errors and logical problems. After incomplete recovery, RESETLOGS creates a new database incarnation, so we should establish a fresh backup baseline. Think of point in time as a time machine, but it only works when we have preserved the recovery information needed to travel back in time. If this helped, like the video, subscribe, and drop your question in the comments.